So I was going to make an answer key for this packet and decided I might as well just go ahead and film it. So here we go. Okay, finding the zeros, the factors of the top over the factors of the bottom. 3, 4, 5, 6, 7, 8, 9, no, it's just 14 and 28. 1, 3, and 9. Notice this was the calculator section, so I'm sure there's like one that's a nice integer or whole number, and then the other three are probably fractions or maybe some imaginaries. And if I give you one of these on the final, I'm not going to make it 28 and 9. I'll make the numbers have less factors. Probably shouldn't have started filming it. I probably should have found one first, but oh well, here we are. So let's just go ahead. I'm going to just cheat here because I don't want to sit here all day looking for one. Oh, dang it. X to the third. Hey, there's 1/3. Okay, so 1/3, that's going to make synthetic division fun. 9, negative 42, negative 143. Like I said, I'll make the numbers easier. I'm sure you guys can handle this. Maybe I don't even need to put this on here. I don't know. 9, 3, negative 39, negative 13, negative 156. What's 156 divided by 3? 52. 52, that's negative 84. 84 divided by 3 is hopefully 28. Negative 28 and 0. Alright. So at this point, to get another one, I'm going to try to factor, but that's a 39. Hey, that might be factorable. Because remember, that's x to the fourth, so that'll be x to the third, so it's 9x to the third minus 39x squared minus 156x minus 84. Trying to factor it, let's see, grouping, pull out a 3x squared, and that'll leave me with 3x minus 13, and then, well, whatever I pull out, I'm not going to get 3x minus 13 in there, so it's not groupable. You get the point, though. I'm just going to use the calculator for the rest. Like I said, without a calculator, I'm not going to make you do crazy ones like this. Let's go to the table. Hey, there's another one, 7. So what, we got 1/3. 7 works. And you can do synthetic division again. You just keep breaking it down and then factoring it. So 7, 9, negative 39, negative 156, negative 84, 9, 56, 13. No, that's not 30. Yeah, I'm done. I don't care. There's one between 0 and 1. So what's that? Probably a third. We already got a third. There's one between, oh, there's another one, negative 2. And there's probably another one. Who cares? Moving on. You get the point. Plug in f of negative 1. Plug in negative 1 for x in this one. So it would just be negative 1 minus 2 minus 3. That's negative 3. Absolute value of negative 3 is 3. 3 minus 3 is 0. G of x equals 3, so you'd go 3 equals the square root of x plus 2, square both sides, 9 equals x plus 2, subtract 2, x equals 7. G of negative 1, so x is negative 1, plug it in there, square root of negative 1 plus 2 is the square root of 1, which is just 1. f of x is -4, so you got -4 equals the absolute value of x minus 2 minus 3. Add 3, and you got -1 equals the absolute value of x minus 2. And then you're like, oh, hey, wait. If I do the absolute value of something, there's no way I can get -1 as my answer, so this has no solution. F of g of 2, remember you do the closest one first, so you do g of 2, plug it in, so you'd get the square root of 2 plus 2, which is 2, and then you plug that in for f, so then you go 2 minus 2 minus 3, that's 0, that's -3. G of f of 2, so now do this one first. So we know f of 2 is -3, so then you take -3 and put it in for that one. You get the square root of -3 plus 2, which is the square root of -1, which is I, or no solution. Usually you only include i's if the directions tell you to include complex solutions. If it doesn't say that, and it's written in this notation, it's usually, you're probably not going to do that. So this one you can add them first straight up, or you can plug them in and then add them. Say g of 7 is the square root of 7 plus 2. F of 7 would be 7 minus 2, that's 5. Minus 3 is 2. So you got 2 plus 3, which is 5. Next page. Solving for x. Let's see. Get x by itself. It's in the exponent. Divide by 1,000. So you got 2,500 equals e to the 0.05x. Now we're down to the x, the variables in the exponent, so we'll log it. So it's going to be log base e. Remember, it's always log little number to this power, so 0.05x gives you 2,500. Log base e is just ln, so this is the ln of 2,500 equals 0.05x. Divide by 0.05. So x equals the ln of 2,500 divided by 0.05, whatever that is. $156.48. Here we go. We got an inequality. X squared and an x in the same inequality. We're going to have to factor. So before we even factor, we got to get all on one side. Do a little distributive property here. We got 2x squared plus 11x and subtract 6 greater than or equal to 0. Factor that. 2x, x, 6 and 2 will make 11. So 6, 2, that's 12. No, that can't be right. Can't be right because those have a 2 in common. And if I can pull a 2 out there, I should have been able to pull it out at the beginning. It looks like it'll work. 12 and 2 don't make 11 though, idiot. So, and they don't even multiply to 6. There we go. It's 12 and 1. It's 2x, 1, x, and 6. Here we go. Plus 12, minus 1, greater than or equal to 0. Now remember on these, on inequalities, where it's not just linear, just solve it like an equation to get it equal to 0. So I'll get x equals 1/2 and x equals -6. And those are critical points. And then I set up test regions, so I got like -6. And then I got 1/2. Say that's 0, that's 1. So everything either in between those or on the outside of those will work for this. So at this point, I just plug in points. So like I plug in a point in this region, so like -7. Or I like to do -1,000,000. -1,000,000 squared is +1,000,000 times 2 is 2,000,000. 2,000,000 minus 11,000,000 is -11,000,000, or negative a whole bunch. Minus 6 is negative more. So no, it's not going to be greater than 0. Wait a second. It should have been. Oh, I didn't square the million, idiot. Man, it's after school. I'm tired. I want to go home. I was going to say, because the other way of thinking about it is like, that's a parabola. So when is that parabola greater than 0? Well, if it's ever greater than 0 at all, it's going to be on the outsides of your x-intercepts. It's not going to be in between them because it's a upward parabola. So it's got to be out here. And we can include, this is just greater than, so we'll have parentheses because we won't include those numbers. And then we could also write it as x has to be less than -6 and x has to be greater than 1/2. Again, I should have plugged in like -7. I should have plugged in 0. Plug in 0, it's easy. 0, 0. -6 is greater than 0? Nope, so it's not in the middle. Plug in points. Down here, common denominator. Ooh, that's kind of ugly. Oh, except 8 plus x and x plus 8 are the same thing. And since those already have a common denominator, why don't I just go ahead and add that to the other side? So I get 4 over x plus 8 equals 4 over 3x minus 2. My initial thought would be no solution, but let's see. Multiply both sides by x plus 8, so it's 4 times x plus 8 equals 4 times 3x minus 2. Well, why don't I just divide by 4 on both sides? That's awesome. So x plus 8 equals 3x minus 2. Subtract x, you get 2x. Add 2, you get 10. Oh, hey, x equals 5. There it is. Check your answer. Yeah, it doesn't make the bottom 0, so x does, in fact, equal 5. Because if you get an answer on these rationals, and then you plug it back in, and it doesn't, it like gives you 0 on the bottom. Like if I got x equals -8, because that can happen, and then you look up here and you're like, oh wait, if I plug in -8, it doesn't work. Then you have no solution. Or if there's multiple answers and only one of them does that, then you just get rid of that one. What do we got here? Equation, x squared. Doesn't have an x, so I don't have to factor. If I could just isolate the x squared, I could probably square root it. So I should do a little distributive property action. 5 plus 100. I'm going to add 400 and subtract 5. Divide by 100. So I square root it. And remember, when you square root, you got positive or -2. Ooh, bonus. Partial fraction decomposition. We did not do this. It's basically like you have this and you got to go backwards and get it into like 2 fractions that add together that give you that. So you'd be like, whatever, nobody cares. Not going to talk about those. Sequences, this is from Algebra 2. Arithmetic is like linear. It's adding the same amount every time. So if it goes 4, 12, like you can make a table. These are always the y's. So and the first one listed is always when x equals 1. So it goes 4, 12. If it's arithmetic, it's adding. So it's adding 8. So you have to write the equation for that. Well, if you know y equals mx plus b, you know the slope's up 8 over 1, so it's just 8x. Your initial value would be -4 if you go backwards 1 on your table. If it's geometric, that means multiplying. Again, that was Algebra 2. So this is multiplying by 3, so that multiplies by 3 is 12, multiply by 3, multiply by 3.
Are you on the phone?
No, I'm making a video. I can pause it. Okay, geometric multiplying, multiply by 3, multiply by 3, multiply by 3, blah, blah, blah. That's like y equals ab to the x. If you recall, initial value, multiplier, so on this one, you got to go backwards. So if you go back, like this way is multiplied, this way is backwards, you divide by 3. So x equals 0, you'd need 4/3 for your y. So your initial value is 4/3. Your multiplier is 3 to the x power. If you're not sure, plug in a number, see if it works. If I plug in 3, 3 to the third is 27. 27 times 4 is 108. 108 divided by 3 is 36. It works. These are the same thing. There's just missing numbers. arithmetic sequence is just like a linear thing. So you have 2 points, and you need to find the equation of a line between 2 points. I hope you remember how to do that. That's old school. This is actually Algebra 1 now, folks. We teach this in Algebra 1, but anyway. Rise over run, right? Changing y over changing x. Stuff like that. So that would be 82 minus 10 over 35 minus 11 for your slope. What is that? 72 over 24. Is that 3? So you got slope of 3. If you know point slope form, it's easy. You just go y minus 10 equals 3 times x minus 11, or y minus 82 equals 3 times x minus 35. Those are the same thing. Don't believe me? Multiply it out, add 10, add 82. That's the way I would do it. If you wanted to do y equals mx plus b, you could go y equals 3x plus b, plug in 10 for y, plug in 11 for x, solve for b. 33 minus negative 23. So it would be y equals 3x minus 23. So any of those answers would work for that. This one, if it's geometric, you know it's multiplying. So you know if you start with 10, you take 10, you multiply by something, and you do it 1, 2, 3 times, and you'll get 80. Divide by 10, by 10, 8 equals b to the third. Third root of both sides, so b equals 2. That means this is multiplying by 2. Check your answer. 10, 20, 40, 80. It works. So if I go backwards, that'll be 5. So your equation is 5 times 2 to the x power. We didn't do much of that this year, so probability of that appearing on the final is small. If it does, it's not going to be more than like one question. These anyway. Arithmetic, I mean, you should be able to find the equation of a line in your sleep. Got a funny story about that actually, about finding derivatives, but if anyone's watching this, if you ask me about it, I might tell you in class. A little story. Okay, solving for x, log equations. Just remember the circle. This is 3 to the 5th equals x. Boom, done. X to the 4th equals 100. So the 4th root, x is the 4th root of 100. Good enough. Oh, I should probably simplify that. Let's see, what's 100? 2 times, or 4 times 25, or 2 times 2 times 5 times 5. 2 times 2 is 4 times... Yeah, so that doesn't even break down. There's nothing I can pull out. So 4th root of 100 it is. Log of 200, that's just I can't believe I put that on the test. That's already solved, so this must have been a calculator. Well, this wasn't even a test, was it? That was just... So anyway, just calculator it up. And it's already log base 10, so that's nice. It's just, can you type into a calculator? 2.3. Same thing here, that one's already done. It's just a matter of knowing how to punch it in. It's the log of 867 over log of 5. You could even use ln, you'll get the same thing. I'm going to do that just to be crazy. What do we get? 420. Wow. Speaking of getting crazy. This one, let's see, we got to switch it to log form, so it'll be log equals little number to this power, little number, so 2 to the x power equals 1,000. So log base 2 of 1,000. So log of 1,000 divided by log of 2, 9.97. And then here, log it up, log, it's 10 to the power of x equals 482015. I wonder what the significance of that number is. Oh, I think it was the date. I must have made this problem on April 8th, 2015. So if we go log 482015, 5.68. We ever graphed logs? It's good to know though, just like, just in general, like in life, you know, all all those situations that have come up in my life where I've had to graph a log. It's really come in handy to know. So, let's see. Chewing. X and Y intercepts are the same for everything. Plug in 0 for Y to get your X intercept. Add 1, divide by 4. Solve that for X. Switch to exponential form. Remember, if there's nothing there, it's a 10, so it'd be 10 to the 1/4 power equals X minus 2. Add 2, so 10 to the 1/4 plus 2, whatever that is. 10 to the 1/4 plus 2, 3.78 is your x-intercept. Y-intercept, plug in 0 for x. Plug in 0 for x, you get log of -2 minus 1. Well, if you know anything about logs, you know that that's not possible, so there is no y-intercept. Because there's no number. This means 10 to what power gives you -2. You can't raise 10 to a power and get a negative answer, so can't do that. No y-intercept. X-intercept's 3.78-ish right there. Asymptote will always occur where that equals 0, because you can't do log. You can't do 10 to a power and get 0 as your answer. So you can't have 0. You can't have log of 0. You can't do that. And you can't do log of negatives, like I just said. So your asymptote always occurs where the 0 would be. So when x is 2, that's where your asymptote would be. That's an asymptote. And then basically, just to make long story short, it's going to look something like that. I don't know. You can plug in points, get more accurate. Let's see, this one. Properties of exponents, beautiful. 4 to the third, 64, x to the third, 81, x. So whatever 64 times 81 is, 4 to the third times 3 to the fourth over x to the seventh. There's your answer. This one, break it down. That's 3 times 25. Square root of 25, I know. Bring it out. Leave the 3 in. 3 divided by 2 is 1 with 1 left over. -4 divided by 2 is -2. Rewrite it without a negative exponent. It'd be 5x times the square root of 3x over y squared. Ooh, this is nice. Lots of factoring. X plus 2, x minus 2. These are going to flip, so I'm going to write x minus 2 up here and then factor that one down here. 2 times x plus 3. Cross them off so I don't get confused. This one, let's see, I'm going to pull out an x first, and then I'm going to factor it like it's an x squared, so it'll be x and x squared. 2 and 3 multiply to 6, add to 5, x plus 2, x plus 3. And that's it. Cancel crap out. I already flipped, so this is just multiply now. X minus 2, gone. X plus 2, gone. X plus 3, gone. What's left? X over 2 equals 14, so x is 28. Same thing here, simplify this side, and then we'll worry about the equation aspect of it. So to simplify this side, do the top, get a common denominator, x times x plus 1. This one gets multiplied by x plus 1. It's just 1 times x minus 1 times, this one needs to get multiplied by x. And that's just the top. Over 1 over x plus 1. Let's see, that's just 1x plus 1 minus x. That's 0, so it's 1 over x times x plus 1. Then I'll flip and multiply right now. So times x plus 1 over 1. Gone. So it's really just 1 over x. So this whole side is just 1 over x. Equals 2. So multiply by x. So 1 equals 2x and x equals 1. I hate this problem because for all the crazy Galen math people, that just go like, oh, hey, look it, there's a 1 mole, I'll just go, psh, psh, and it's 1 mole for x, and it works on this problem. And that's the only one it works on. And I hate this problem for that reason. So this exact problem will not be on your final, but maybe something similar. You just need to put some, if I like just throw a different number on top of anything, it doesn't work. So, or just make any number different than a 1. Okay, next page. Hey, I think I went over the next page already with you. There's a red pen on here, so I must have gone over it in class. There's f of g of 4 again. Do that one first, you get 10. Plug in 10 for that one. 100 plus 40, 140 minus 12, 128. X of f of x equals negative 18, so put negative 18 over there. Negative 18 equals that. I'm going to have to factor, add 18, so that's x squared minus 4x plus 6 equals 0. Factor that. Can't. Shit, that's freaking quadratic formula. 4 plus or minus square root of b squared minus 4ac over 2. Technically, I didn't say to include imaginary answers, but hey, what the heck? 4 plus or minus square root 16 minus 24, what is that, negative 8 over 2, square root of negative 8 is 2 root 2i, 4 plus or minus over 2, so it's 2 plus or minus the square root of 2i. Beautiful. That's inverse, that little negative 1. That one had no inverse because it was a parabola. If it asked for the inverse of g, remember that's just good old switch x and y, solve for y. So you'd go x equals y plus 6, subtract 6, y equals x minus 6. There's your inverse of g, just for fun. Okay, there's another find the x-intercepts. Yeah, I think we did that one in class. Hopefully you know the process. Whether you're successful or not, I don't know, but you know how you need to do it. That one, yeah, we went over that in class. What's left? Different types of numbers. Those are natural numbers. Those are irrational because they're decimals that never repeat. They go on forever and never repeat. Those are integers. Those are rationals, decimals that end or repeat, or fractions. Generally rationals means fractions, but these can be represented as fractions. Those are those are whole numbers. Natural numbers don't have 0 in it, because whatever. And those are complex. Anything with an I is complex. This bonus problem, solve for x. It's actually really easy. If you simplify this first, I to the 48th is, let's see, I to the 4th to the 12th, so that's 1. This is I to the 4th to the 5th times I squared. Well, that's just 1. That's negative 1. So it's 1 minus 1, which is just 0. And 0 times all of that is just 0. So really you got x equals 2x minus 6. So x must equal 6. Hey, there's another partial fraction decomposition. I don't think that's not in must not be in Big Ben's book, because we never came across it. It's in our Precalc book. I don't know why. I mean, whatever. What do WSU fans and most UW fans have in common? The answer to that is neither of them went to UW. Or they didn't go to UW, I guess you would say. Oh, is that it? Yes. Awesome.